Would you write it like this or would you write it like this?
You told me not to write it like that, is all that I'm trying to talk.
Okay, I didn't know if you write it like.
If your negative three, your 3 and negative 4 is replacing negative 1, they're all x's. So that plus 3x and minus 4 would need to have x's on them.
So what are we doing today? Are we
What does it say we're doing?
Solve quadratics.
Here you go.
So that was simplifying square root, solving quadratics. Oh,
What's the GCF in the first parentheses? Everything does great, you're doing great. What do 2x squared and 3x have in common? So take an x out of that. It's still got a 2 on it today, right? You had 3x, and you're taking x out. So you just have a plus 3 left. And now we wanna end up with the same thing, so what can we take out? Well, hold on. Yeah, but make it a negative 2 to make your signs work, yeah. Good job. So now, we have twice, so you write 2x plus 3. And then what? So if you took this away, you'd have an x left. If you took that away, you'd have a minus 2 left. Yeah, both of them in parentheses. So now the last step to solve is to set both those parentheses equal to 0 and solve. That's the so that's pretty good stuff there. Okay, so let's go through these pretty quick. This took you back to review solving by factoring, because today we're gonna look at something else. So the first one, number 1 there was your easier one. It's already ready to go, it's already in standard form, your A's a 1, so you just did 1 times C and got 30. What multiplies to make 30 but adds to make 11? 5 and 6. So then when you set each of those equal to 0 and solve, x plus 5 equals 0 just gives you x is negative 5. And x plus 6 equals 0 just gives you x is negative 6. So that was your easier one.
Can you remember that part, please?
Thank you, Mr. Austin. Alright, number 2, a little bit more work to do. Number 1, it's not ready, and so you need to set it equal to 0, so you need to get rid of the 2x, so you'd subtract 2x from itself and from its buddy on the other side. I got really intrigued when I was watching Leilani work that, because she subtracted just an x. But she knew, she worked it out and there was an x left, so then she went and subtracted x again. So she did the same thing, just a different way, so that was kind of cool on that, Leilani. Also gotta subtract 6, there's nothing to subtract it from over there, so it's just gonna get stuck on the end. So I'm gonna have 2x squared, x minus 2x is negative x, and then there's my minus 6 stuck on the end. Okay, so then when you do your a times c here, this time our a is not 1, so it's gonna take a little bit longer. Our a is 2, come on scroll, there we go. So 2 times negative 12 is negative 12. The things that multiply to make negative 12 but add to make negative 1.
Where'd you get the negative 12 from?
A times c, 2 times negative 6.
Okay, yeah.
So it's negative 4 and 3 are my factors I'm going to use. I'm going to put them in the order Leilani did because she worked it out over there. She put the 3 first, so 2x squared plus 3x minus 4x minus 6. So then you put them in your groups. If you put the minus 4x first, it would still work. But now, the way Leilani had it, she just took an x out of that first group. So that left with 2x plus 3. Take a negative 2 out of this group, leaves you with 2x plus 3. And let me scroll down, we'll get down in the way of that other problem. I'm gonna scroll it, I hate when my scroller jumps sides, hold on, let me scroll it. Okay, so your answer here would be the 2x plus 3, because you had that twice, and then what's left, the x minus 2. So now just set both of those equal to 0 and solve. I'm coming way up over here now. 2x plus 3 equals 0. Two-step middle school equation. Subtract your 3. 2x is negative 3. Divide by 2. And x is negative 3 halves. Then my other one, x, go ahead.
2.
Yes, so x equals 2. Good job, Ariana. So there's your 2 answers. Alright, so get all that cleaned up, fixed in your notes if you needed it, and then we're gonna go back to square roots. We reviewed square roots on Friday. Today we're gonna use it to solve equations. It's pretty easy stuff. Everybody have a good weekend.
Yes, ma'am.
Won't be long now. When I was walking up from the bus today, Coach Guthrie was on parking lot duty, and he hollered at me 7 days, and I was like, but that would be 7 days before semester tests.
Yeah.
So that makes it sound a little bit better. Semester tests are, you know, that's different. Some of y'all won't
Do
even
you
be
like
here.
semester tests?
Do I like them?
Yeah.
I mean, I don't feel strong one way or the other about them. You gotta take semester tests most of the time in college, so it's good practice.
Oh, yeah, you do that for me.
That's just how it is. They call it finals. Alright, let me get my blank page, there it is. Okay, so talking about when we're going to solve using square roots. If this is standard form of a quadratic, and we've talked about that before, right? We're all good on that. I'm putting equals 0 now, we could put equals y. We could not solve that using square roots. There's good times and bad times for all these methods. This is our third. The good time to use square roots is when you don't have a b. Okay? So when we don't have a b, that's when we're going to do what we do today. Alright? So first thing we'll want to do is isolate the x squared, get the letter all by itself.
So what do we write? So we don't write the top, then?
I don't care. That's standard form. You might need to know standard form.
So we're solving this problem?
No, that's standard form. I haven't given you one to solve yet. Okay, so first thing we're going to do is get the letter all by itself. And then once we get the letter all by itself, we'll have to know how to undo a squared. And that's what we reviewed on Friday. How do you undo a squared?
Divide.
No. How do you undo a square? Square root. Very good. And you've still got a chart in your notes if we need it. So let's look at this one. I got x squared minus 64 equals 0. So first thing I want to check for, it's a 64, kind of looks like a y, 64. X squared minus 64 equals 0. First thing I want to check for is, does it have a b?
No.
No. So I'm good to use square roots. That's a shortcut. It is difference of squares, and we covered difference of squares last week by factoring, so you could do that. This is just another method. I said you need to get the letter all by itself, so we need to get rid of minus 64. How do you get rid of a minus? Add 64 to both sides. that gets you x squared equals 64. Now, how did we say we undid a squared? So x will equal, remember when you square root, you're positive or negative. And what's the square root of 64?
8.
So we could be positive or negative 8. That's it. So this makes it more of an algebraic approach. You solve that like you would a normal equation. You undid things, did opposite operations. Okay, how about 7x squared plus 8 equals 15? Can I solve this using square roots?
Yeah.
Why?
Is it gonna have B?
And how do I know there's no b? You're right, you're right.
Because there's no B, there's no B.
Okay, there's no x to the first, so there's no b. But I got my c, I need to do something. I got an 8 on one side and a 15 on the other side. So what am I going to do with that?
Subtract the 15.
I could
Subtract the 8.
subtract the 8 would save me time. If I subtracted the 15, I wouldn't be wrong, but then I would have to then go ahead and move it back over to the other side. So just go ahead and subtract the 8 in the beginning. That gets the x squared almost by itself. It's not quite by itself. What can I do to get it by itself?
Divide.
I get it's got a 7 being multiplied by it, so we divide by it. So we got x squared is 1. Undo your squared. What undoes a squared? Square root, positive, negative every time you square root. And what is the square root of 1? 1. Want to win it? Chicken dinner. Alright, let's look at 8x squared plus 1 equals 17. Alright, I'm going to let you try that one, and you're going to run into something we haven't done yet today. We did it Friday, but we haven't done it yet today. See what you can come up with. I'll give you just a second.
Because
What are you going to do with it?
I don't know.
Just leave it. Alright, so we're going to subtract our 1. Everybody agree?
Yep.
Okay, so it gets us 8x squared equals 16. And what?
Divided by 8.
Good. So it gets you x squared is 2.
And 2 is not a square root, right?
Well, tell me what to do next.
Just keep it as that.
No? Okay, I do a squared by square rooting. Now, here's where it was different. Is 2 on the right side of your list? Is it a perfect square?
No.
No. Will a perfect square go evenly into 2? Can I break it down? No. So that's it. That's your final answer. A lot of people get scared of that and think that can't be an answer, but it is, and it's really less work because you don't have to do a square root of 2. You just leave them. Now, when they become a little bit more difficult, so what we're going to look at next is when what's in there can be broken down. Okay, so let's do one of those. So we got 2x squared minus 9 equals 55. Okay, let's do this one together. Tell me how to start.
Add the 9.
Add the 9, sir, talent. So I got 2x squared is 64. Then what?
Divide by 2.
Divide by 2. So that is 32. How do I undo a squared? Square root. Alright, so let's check out our number in the radical 32. You got your list of perfect squares. Is that on the right side?
It's between 5 and 6.
But is 32 there?
Oh.
No. So then we find what the closest one is, and Kinley's right. It's between 36 and 25, right? So we're going to start with 25. And we're gonna work backwards and see which of our perfect squares will go evenly into 32. So 32 divided by 25, is that a whole number? Nope. So next is 16. 32 divided by 16, is that a whole number? Yes. 16 goes into 32 how many times? 2. So this is the same as square root of 16 times 2. Okay? Now, what is the square root of 16? 4. So you bring a 4 out to play wiffle ball. 2 stays in the house to do chores. Winter, winter, chicken dinner. The square root of 16. You got it, ma'am. Okay, I'm gonna let you try one of those now. Got what you need on that page? About 4 minus 3x squared equals negative 77. So I would get rid of the 4 first. That's just what I would do. Don't forget your plus minus sign. Great job.
Is this right?
Don't forget plus minus sign. Great job. Those y'all that are still unsure, I've not finished it, but you can go back and check and make sure you got what I had at that point. And then we'll finish it together if we need to in a second.
Hey, Coach.
Very good. Alright, so under the squared, so I'm gonna square root 27. So look down the right side of my sheet that we made Friday for perfect squares, and 27 is not there. It goes from 25 to 36, right? So I'm gonna pick the smallest one close to it, so 25. I know 27 divided by 25 is not a whole number. Next is 16. I know 27 divided by 16 is not a whole number. Next is 9. Ding, ding, ding. How many times does 9 go into 27? So I got the square root of 9 times 3. Now what is the square root of 9? So you bring that 3 out to play wiffle ball right there. Square root of 9 is 3. And you leave that 3 in the house to do chores, and you have got it. How'd you do? Yeah, how'd you do? You got that one, but how did everybody else do? Good? Alright, let's try another one. I'll let you try this one on your own. remember, the only time we do this, what we're doing now, is when there's no b. So that means there's no x to the first power. It's a 310. 5, I got worse when I tried to fix it. 5x squared plus 10 equals 310. All right, see what you can do with that. No. 6 and 10, neither one of those are perfect squares.
Oh, so that's not. But that's
No,
it.
it's, the perfect square's gotta be on the right side.
Oh, so sorry.
That's okay. Better now than on a test or something.
Wait, what? What if the number does go into it, but it can't get the square root?
You're choosing the numbers that are perfect squares, they're the ones on the right side. So you're checking the numbers on the right side.
Now will you check this?
Yes, ma'am, good job. So I've got mine down to the square root phase. I feel like you probably got there pretty easy, right? Once we get there, we're dealing with squares, square roots, we need perfect squares. So like 20 and 3, I know I can multiply 20 and 3 to make 60, right? But neither one of those are perfect squares. So you gotta make sure you're choosing the numbers on the right side of your perfect square list. The closest one underneath 60 would be 49. That won't go evenly into 60. Then 36, that won't go evenly into 60. 25, that won't go evenly into 60. 16, that won't go evenly into 60. 9,
Nope.
nope. 4,
Yes.
yes. 60 is the same as 4 times 15. And then what's the square root of 4? 2, so you have 2 square roots of 15.
I did the same thing. I did mine backwards.
Yeah, that's fine. You still got the same answer, right? Oh. But when you got that funny answer right here, you should have said, uh-oh. Because it's gotta be a whole number that comes out to play with the ball.
That was 4.
What you think? Not too bad? I hope.
No, not too bad.
Not too bad. So, here's, where we are, where we're going and all that kind of good stuff. We've done solving quadratics by graphing, we've done solving quadratics by factoring, and we've done solving quadratics taking square roots. Square roots can only be done when you don't have a b. Factoring can only be done when it's factorable. Not everything is factorable. Graphing, it can be done any time, but you might have a hard time finding what you're looking for if they're funny fractions or decimals. So far, the three of the methods that we looked at, I got good times to use and bad times to use. Okay, tomorrow is our, NWEA map test for 10th graders. So 10th graders are gonna do that during this class tomorrow. Juniors and seniors are gonna find something quietly to work on and not bother them. Okay, then Wednesday, we're gonna have to start looking at imaginary numbers. Cause our next methods, we might be able to get imaginary numbers in.
Because we having that quiz.
Let me see, cause I do have down to do that. Ooh, that might be Wednesday. That might be before the imaginaries. Yes.